Hey there, TouchDesigner developers. Jack DiLaura here with the Interactive and Immersive HQ. In this video, we're going to work through recreating the style of Ryoji Ikeda in TouchDesigner. This is the final piece that we'll be generating today. And just in case you have not yet heard of Ryoji Ikeda, he is a visual and sound artist who is well known for very minimalist works of art. In the kind of sonic category, he's often dealing with things like simple sine waves at high frequencies. And in the visual world, he's often creating work that is very pixelated, monochromatic. And we're taking inspiration from this photograph from one of his live sets from a couple of years ago. We're not making an exact replica of this. It's definitely a little bit different, but takes the general composition as its inspiration. So let's just briefly take a look at two other pieces of Ryoji Ikeda's work. You can see here a gallery installation from a couple of years ago as well, showing that he is also creating prints in this sort of similar aesthetic with these monochromatic bands. Again, these have a sort of rhythmic quality to them, even though they're just static images, which is a kind of interesting through line in Ryoji's work. And here is a picture of a projection installation, again from 2019, that is actually using text, but in a repeated sort of fashion, which again is bringing this like pattern-based rhythmic feel that we've seen in his other work. So with that, let's jump into building our recreation. Okay, so starting with a blank network, we're going to begin by creating some SOP geometry. We're going to be using instancing as the core of this effect today. So I'm going to grab a rectangle SOP first of all and place that into my network. Within the rectangle, let's go ahead and change our size parameter here. So I'm going to set the size to 40 by 3. Cool, so that gives us that kind of skinny bar shape from the Ryoji Ikeda piece. And then let's add a null and follow that up with a geocomp. Now that we have a geocomp, let's go ahead and add a material. I'm just going to add a constant and drag that onto the geo and hit parameter material. Within the constant, let's make sure to head to the common page and turn on blending transparency because we are going to have some alpha channels applied to our instances. Now we might as well set up our pretty short rendering pipeline and kind of top section of the network now, just so we can see what is actually happening to our project. So to do that, I'm going to first head to the comp page and grab a camera and add that to the network. Oops. And we'll place that to the right of the geo. Then after the camera, we're going to add our render top. So the render top, I'm just going to leave at the default 1280 by 720 resolution in case you are working with the educational license. Now that we have that set up, I'm actually going to head back to the camera and make some changes. So on the view page, I actually want to use an orthographic projection because we're dealing with a kind of straight on two-dimensional artwork today. We don't really need that perspective component. And then for our ortho width, we're going to connect that to the width of our render, which will in effect give us the ability to use these scale parameters here, the size parameters for our rectangle, as if they were pixel values. So how do we do that? We head back to Cam 1, we click on the ortho width parameter, and then we'll make a chop or an expression reference to the render 1 width parameter. So let's go ahead and type that in now. So op, open and close parentheses, single quotes, and then we want to grab render 1. And then at the end of that, we want to type in dot par and then dot resolution W for width, which should give us a value of 1280. So we're all set within the camera now, and we should see a very, very small little bar at the center of our screen. The only other thing we're going to do with this rendered output is add a background into it. So I'm going to grab a constant, connect it to the render, and then for my color here, I'm just going to turn this to like a sort of dark gray color, maybe like 0.3 in the color parameter. Then I'm going to head over to the output page and change the operation here to under, which will composite our rendered output with the background, and we should see our little bar is now floating on a gray background, which is just great. So I'm going to attach a null to that for good measure in case you want to add any additional operators. And now we can actually dive into the instancing and then applying color to our instances, which is really where all the magic of this patch happens. So for the instancing, it's going to be pretty simple. We're just going to use a grid SOP to define our point positions. So let's grab the grid, and then we've got a couple of things to change within that operator. First of all, our size settings we need to adjust. So for size X, we're going to set that to 1240. Oops, not 1280, 1240. And then for our size Y, we're going to set that to 717 and hit enter. Then we're going to change the number of rows and columns. So for the number of rows, I'm going to set that to 240. And then for the number of columns, I'm going to set that to 32. Cool. So I'm going to add a null and rename this to null POS for positions. And then I'm going to head back to the geo, head to the instance page, turn instancing on, and then drag null POS onto the translate operator parameter. Then I'm just going to go ahead and pull in the P0 channel for translate X, P1 channel for translate Y, and P2 channel for translate Z. We should then see in our final render that our screen is now completely white. That's because we have, how many rows and columns? 240 by 32 rows and columns of those little bars that we set up at the beginning, which is completely covering the screen. So now we actually are going to add color to those instances, which will generate the effect that we saw at the beginning. So this is all about adding color to our instances and really doesn't have anything to do with the instance positions themselves, other than the fact that they're in a grid. So to begin here, we're going to grab a noise top. So if you remember in the initial composition, we have like a kind of random left side of the screen, which we can just head back to our image here. We have a kind of random dispersion of bars on the left and then this sort of sine wave pattern on the right. So we're going to focus on this left half first, and then we'll build out the right half. So let's head back to Touch. Now to set that up, we're going to add a noise top and make some changes here. So I've got to do a number of different things to set this up. First of all, on the common page, we're going to set our resolution. So we're going to grab our resolution width and height values from the grid to essentially give us the same number of pixels as we have instances. And actually, I take that back. In this case, because we're splitting the screen in half, we're going to have half as many pixels as we have instances because we're going to be combining it with another image, which will be on the right. And at the end, we'll have the total number of pixels that we have instances. So this is going to be a little bit different than normal in that sense. So let's make a reference here to access the rows and columns parameters of the grid. So op, open and close parentheses, single quotes, grid 1 is what we're trying to access, and we want for our width parameter dot par dot calls, we want to grab the number of columns. And then as I said, we're going to divide that by 2 because we're only wanting to cover the left half of the screen. So That should give us a value of 16. Then we're going to do the same thing for the resolution height parameter. I'm just going to copy and paste this so I don't have to type it again. And then I want to reference the rows parameter for resolution height. So we should have at the end 16 by 240. Now, to attain that very pixelated monochromatic look, we're going to turn in pretty much every situation that we can in this patch our input smoothness and viewer smoothness to nearest pixel. So I'm going to do that now. Then we can head back to our noise page and make some quick adjustments there as well. So I'm going to set my period here to 0.04, which will give us a much more grainy pixelated look. Then I'm going to set my amplitude to 0.7, which will brighten things up a little bit. That's all we're going to do on this page. We'll then head to the transform page where we're going to add an ABS time.seconds expression so that this noise will shift and change slowly over time. So I'm going to type in ABS capital T time.seconds, and then we're going to multiply that by 0.1. You'll see now that the noise is slowly shifting over time. After that, we're going to add in a limit top to basically limit ourselves to values of 1 and 0 in our color channels. So let's go ahead and grab the limit top and place that to the right. On the quantize page, we will turn our quantize value parameter to floor. Then we're going to set value step to 1. What we should then see is that our output has changed pretty dramatically. We only have, as I said, values of 0, which is black, or white, which is 1. Another thing we want to do here is to ensure that we have set our input smoothness to nearest pixel and our viewer smoothness to nearest pixel so that we get nice sharp pixels. So that's looking pretty good. We might want to come back and adjust that later depending on how our final composition looks. But other than that, I am realizing that I believe we forgot to do something. Ah, yes, we shouldn't be seeing black here. We should actually be seeing a transparent alpha matte instead of the color black. So let's head back to our noise and head to the output page. Here we can actually decide how we want to set our alpha, and I want to do that based on the noise that we're generating. Once we do that, we should be then seeing a transparent background and then the white pixels on top of that. So that's how it should look at the end of making those changes. So that gives us the, although it doesn't look like much, it will give us the white bands that we see on the left of the screen, but we also have some black bands interspersed with those white bands. So we're going to approach that in a very similar way and composite the two final outcomes together. So let's go ahead and copy and paste these two things, make some adjustments to the second copies, and then we'll composite them together. So for our noise here, let's go ahead and make some changes. First of all, I want to make sure that these are not generating the exact same noise pattern. So I'm going to change my seed to any random number you want besides 1. Our period's going to stay the same. Our amplitude we can decrease to something like 0.5. And then assuming we've got all of those changes made, you could do something maybe like change the ABS time.seconds multiplier to slow down that rate of change or speed it up so they're a little bit different in that sense, but I'm just going to leave it the same there. In our limit, we're going to actually leave that alone, but we're going to attach a third operator because we want these pixels to be black now instead of white. So I'm going to accomplish that with a constant. So let's place that to the right, set our color here to black, and that should have the effect of immediately turning our little pixels here to black because the output operation is set to multiply with the input. Now you might have noticed that we have some fuzzy pixels here again, so we can go ahead and set our nearest pixel for input and viewer smoothness, and we are all good to go there. So we can then composite those two things together. And I will use an operation here of over, which we can then see has the effect of combining those two patterns together. And again, we're going to set the input smoothness and viewer smoothness to nearest pixel. Okay, so just for a brief aside to show you what we've just accomplished, since we can't actually see it in its final application yet because our pixel dimensions are not correct, I've just added a fit top to demonstrate. Here is what the pattern that we've generated here looks like when applied to our instances. Now, it's important to note that this will be on the left side of the screen, but you can see here that we've already generated the pattern that we saw at the beginning of this tutorial. So with that complete, we're going to move on to the next section, which we will be generating the sort of moving sine wave patterns on the right side of the screen using feedback. So I'm going to go ahead and delete that fit because we're not going to need that. And then I'll go ahead and delete our color operator that I added in to the geo to get rid of our error message. So for the sine wave patterns on the right side of the screen, we're going to start off with a rectangle top and place that over here. We're going to be using a number of chops to both move this around and to modify its color over time to give us that kind of choppy, pixelated look that the original Ryoji Ikeda visual had. So to start, let's go ahead and make some changes in this rectangle. I'm going to come to the common page first of all, and we need to set our resolution. Now the resolution that we're going to set is actually going to be identical to what we have applied within our two noise operators. So I'm going to go ahead and copy that so we don't have to type out these expressions again. So head over to noise 1, right click on the resolution parameter title, hit copy parameter, head back to rectangle 2, and on the common page, mouse over resolution again, right click, and hit paste expressions. That should change the resolution there to 16 by 240, just like our other example above. I'm going to set nearest pixel again, and then head to the rectangle page where I'll make some changes. So I'm going to set both the size and center positioning to the pixel mode so we can specify at what pixel value we want to center and size our square with. Then I'm going to set the size to 3 by 1. It has now disappeared because we have anti-aliasing on, which we'll turn off right now. There we go at the center there, our very small little bar shape. I want to set my justify horizontal to left and my justify vertical to top. And then we are all good to go there. We now are going to add some chops to move this rectangle around and to modify the fill alpha parameter. So for the position movement, I'm going to add an LFO chop. And we're going to make just a couple of changes here. I want to set my frequency first of all to 0.125. And actually that's all we're going to do with this one. We are going to use a math chop after that to adjust the range of the output because we're working in pixel values now. So on the range page of that math chop, let's set the from range to -1 to +1. And then in the to range, we actually want this to go from 0 to 13, which seems somewhat random, but actually will allow our little rectangle to stay on screen and kind of oscillate between the left and right boundary. So with that done, I'm going to add a null, and then I'm going to call this null rectangle, or rect POS for rectangle position, We can then make a chop reference from that channel and apply that to the center X parameter. And we should then see our little bar moving left and right, which is just perfect. So after that, we're going to add a noise chop, which is going to basically flicker very quickly this fill alpha up and down to give that kind of choppy, pixelated look to our final feedback. So I'm going to add the noise chop. I'm going to make a number of changes here. First of all, I'm going to set my period as low as it'll go. So just take that slider, drag it all the way to the left. I will then head to the time or the common page and turn time slice on. You can see it's kind of freaking out after that, which is great because that's actually what we want. I'll turn the viewer off here just so we don't have to watch that going insane. Then we're going to add a limit here to quantize our values so that they only ever fall at a value of 0 or 1. So again, we'll turn the viewer off. Or actually, we'll leave it on for a second just so you can see the outcome here. I'm going to set the quantized value here to ceiling and turn value step all the way up. We'll then only have values of 0 or 1, which will have the effect of almost turning our little bar on and off. So I'm going to turn the viewer off there, add the null after that. We'll call this one null alpha, or I guess null rect alpha. And then we'll make a chop reference from that to the fill alpha parameter on our rectangle. We can then see that that is flickering on and off really, really rapidly, which is going to work just great for our final effect. So this looks good. And if we were then to send this into some feedback, we could generate the sine wave pattern just from translating the feedback downwards, which we'll get to that. But before we do that, the sine wave pattern actually also had a black sine wave, which was sort of composited together with the white one. So to accomplish that, I'm actually just going to copy and paste this so we don't have to do any additional work here. Paste that below, and then let's go ahead and move that down because we're going to add something in between these two operators. We'll just make a couple of quick changes here to make our second rectangle have a little bit different of a movement pattern and appearance. I'm going to change the frequency of the second LFO to 0.225. I'm going to move this phase value to 0.145. And that's all I'm going to do there. For our noise, I'm just going to change the seed and the period. So I'll set the period to, or the seed rather, to something like 10. And I'll bump the period up to 0.1. Cool. Finally, within the rectangle, we need to make chop references to these new operators that we've created because it's still connected to the previous set. And then we also need to make sure that our fill color is black. So I'm going to go ahead and set that now by reducing those values to 0 for the fill color. Then I'm going to make chop references from null rect position 1 to the center parameter of that second rectangle. And then I'll do the same thing for the alpha for the fill alpha parameter. So now that is running its own course, doing its own sort of pattern of movement. And in between these, we're going to add a noise top, which will have a very, again, sort of pixelated, grainy pattern, which we're going to use to actually, again, amplify the sort of pixelated look of the final output. So let's go ahead and add the noise top. Oops, well, that came out completely wrong. Okay, noise top. We're going to use that same resolution that we've been doing all along. So I'm just going to go ahead and copy and paste that again so I don't have to type it out. So grab it from either of the rectangles or the noise, copy the parameter of the resolution, head to the noise, the new noise top that we've set up, head to the common page, right click on resolution, hit paste expressions. Then we're going to head back Oh, actually, before we move on, let's set our nearest pixel value here as well. Then we'll head back to the noise page, and we're going to make a couple of changes, including our period, which we'll set to 0.01. We want to add on the transform page some ABS time.seconds expression to move this around. So again, we're going to type in ABS time.seconds for the translate Z parameter, and we will then multiply that actually by 100 in this case. So it's kind of rapidly shifting. Then on the output page, let's set the alpha here to noise, and we're all good to go. We're going to follow a similar pattern to what we set up here and add a limit to make sure that those values are only 0 and 1. So we'll place the limit top to the right, and in this case, we're going to quantize to or using the round setting, and again, use the value step of 1, which will give us, again, pixels of 0 or 1. Let's go ahead and set nearest pixel here too, and then we can actually start compositing these things all together and applying feedback to them, which will generate the sine wave effect. So we're going to actually do 2 independent composites first, and then we will go ahead and composite both of those things together. So to start, we're going to connect the rectangle2 parameter or operator to the comp2 op that we just added, and then we'll add the limit as the second input there. We're going to use a operation of multiply, but we do want to make sure to set nearest pixel again. It's probably easier just to right click and select everything and apply nearest pixel at the end, but can't be too careful because it will make the final output look different. Let's go ahead and copy and paste that composite so that we don't have to do that again. And we're going to replace this first connection from rectangle 2 with a connection from rectangle 3. So I'm going to click and drag from the output of rectangle 3, mouse over that first connection and let go. Now we have 2 different noisy rectangles that have been composited. And you can see here the effect that that's having is to break up that bar a little bit and give it a more pixelated look, which again doesn't look like much now, but when we apply feedback will actually be important. So finally, before we head into our feedback loop, let's go ahead and add a final composite to bring the black and the white rectangles together. So I'm just going to connect both of those to our next composite, set my operation here to over, make sure that I've got nearest pixel applied, and then we'll add a null for good measure. And now we can jump into feedback. So to start, we need, of course, the feedback top. We will then attach a null, and in between the null and the feedback, we're going to add a transform. We'll wait a moment to mess with the transform so that we can kind of come back and have a look at our handiwork. At the end here, we're going to add in a composite, and we want to connect the null to that composite as well as the null prior to the feedback loops, which should be null 3. Within the composite, we're going to set the composite operation to add. And then, of course, we don't have any feedback being generated yet because we haven't set a target top within our feedback top. So to do that, let's just go ahead and click and drag comp5 onto the target top parameter. And then what we should see is that this upper bar will kind of fill up because we're not actually doing anything other than applying feedback over kind of a static area, or nothing is really transforming the feedback in space yet. So before we move on, let's just go ahead and right click, box select everything, set nearest pixels so that we get a nice pixelated feedback effect. And then if we head to the transform, we can start to play around with some parameters. So we have a white bar at the top, our movement is lost, but if we start to play with this translate parameter and even increasing it, or actually decreasing it to a value of -0.05, we'll immediately start generating this very blocky, pixelated pattern, which if you notice here is actually moving in a sine wave pattern. Now, because we set up the LFO chop that is creating the movement for these slightly differently, you can see that these kind of independent sine waves are interwoven, but also sort of moving independently of each other, which is a pretty cool effect. So that is looking good. Let's go ahead and add a null at the end. We can then finally take our two outputs here, composite them, or actually using a layout top, combine them, and then apply that to our geo and have the final effect that we were looking for. So I'm just going to kind of scoot this whole section we just worked on back in space a little bit so that it is a little more aligned with the other section that we've created. Just for a little bit of a cleaner network. Actually, let's just get those composites close to lined up, and then I'm going to add a null up here as well. Great. So as I said, we're going to use a layout top to place these two textures next to each other. I'm going to connect null 6 to the layout top first, and then null 5 second. So again, that's our random pattern first, and then our sine wave pattern second. Within the layout top, we are then going to turn the scale resolution parameter on. We're going to leave the left to right setting alone. We don't really need to do anything here with our fit parameter, just because we've turned that scale resolution on and we've kind of already preset our resolutions to work correctly. So that's all good. But we do want to, of course, set nearest pixel once again. Cool. So finally, at the end, let's add a null. We're going to call this one null color. And without further ado, let's head back to our geo and drag in on the instance 2 page, head down to the color section, drag in null color, and then you'll want to grab the RGB and alpha channels from that operator by using the drop downs on the right. And if we look at the final output, you can see that we have successfully recreated the effect that we saw at the beginning of the video. So I hope that was interesting for you to put together, even though you couldn't really see much of what was going on for a lot of that video. Hopefully this gives you an idea of how you can start to work with simple things like instancing and texture operators tops to generate these sort of interesting minimalist patterns, and also how you can use feedback to in combination with things like chops to create these sort of waveform style patterns. You can, as always, take this project a lot further by playing around with something like different waveform patterns in the LFO chop that is controlling our sine wave portion of the effect. You could change the scaling and or the coloring of the bars that we set up. You could also play around with the feedback loop. There's, limitless exploration that can be done with feedback pretty much. But with that, we are going to close out the video. So I hope that you have enjoyed putting this together. Thanks so much for watching. Looking forward to seeing you in the next video.
Hey guys, thanks for watching. If you're serious about taking your TouchDesigner and interactive skills to the next level, I highly recommend you check out the Interactive and Immersive HQ Pro. It's the only educational resource and community of its kind for TouchDesigner and interactive professionals. You can learn more by checking out the link in the description. And if you like this video, don't forget to hit that like button. And if you're new here, don't forget to hit subscribe and the little bell icon for more awesome free content.